Here is an impossible fact. The number of particles in the universe is not a fixed number. We're taught that matter is objective, that a proton is a proton, regardless of who is looking at it. But this is a lie. If you float in the deepest, darkest void of interstellar space, your thermometer will read absolute zero. The vacuum is dead, silent, and empty. But if you were to ignite a futuristic engine and accelerate through that exact same void with sufficient violence, that thermometer would begin to climb. The nothingness around you would start to glow. It would warm up, then simmer, and finally roar into a blinding inferno. This is not friction. It is not heat radiating from your engines. It is the vacuum itself boiling into existence because you are moving through it too fast. This phenomenon is known as the Unruh Effect, and it shatters our intuition about what empty space actually is. To understand why the void can burn you, we have to look at what the vacuum really is, according to quantum field theory. We used to think of space as a stage, a passive container where events happen. But quantum mechanics reveals that the stage is made of wood that is constantly warping and shifting. The vacuum is not empty. It is the ground state, the lowest possible energy setting of the universe. It is seething with virtual particles, ghostly pairs of electrons and positrons that pop into existence, borrow a tiny debt of energy from the universe, and then instantly annihilate each other to pay it back. In an inertial frame, when you are floating still or moving at a constant speed, these fluctuations wash over you like a calm sea. You pass through them, and they cancel out. The net result is zero. The water is flat. But acceleration changes the rules of the game. When you accelerate, you are not just moving through space, you are disrupting the delicate balance of these quantum fields. By changing your velocity, you pump energy into the system. You are no longer a passive observer letting the waves wash over you. You are crashing into them. The mathematics of the Unruh effect predicts that an accelerating observer will see those virtual, ghostly fluctuations promoted into real thermal particles. The vacuum owes you nothing, but your acceleration forces it to pay up. You are literally kicking particles out of the quantum vacuum. The most disturbing part of this theory is the paradox it creates between two observers. Imagine you are in that spaceship, accelerating at an ungodly rate. You look out the window and see a bath of hot photons roasting your hull. You measure a temperature of thousands of degrees. You can boil an egg in the empty space outside your ship. But now imagine I am floating peacefully just a few kilometers away, watching you fly past. I am not accelerating. My thermometer reads absolute zero. I see you flying through cold, empty darkness. I see your ship heating up, but I don't see the fire you are flying through. I just see your hull glowing for no apparent reason. Who is right? Is the space hot or is it cold? Are there particles there or are there not? The answer is the most uncomfortable truth in modern physics. We are both right. The existence of particles is relative. Temperature is relative. Reality itself depends on your trajectory through spacetime. To you, the vacuum is a furnace. To me, it is a freezer. The universe does not have a single objective history. It has a multitude of subjective experiences, all equally valid, all contradictory, held together by the bizarre logic of quantum acceleration.
From that paradox emerges a dark geometric truth. Why does acceleration turn nothingness into fire? The answer links your spaceship directly to the crushing dark heart of a black hole. When you accelerate, you are doing something profound to the geometry of spacetime relative to yourself. You are creating a horizon. Think about it. If you accelerate forward at a constant, tremendous rate, there are light beams behind you that will never catch up to you. You are outrunning a section of the universe. No matter how long those photons chase you, your increasing speed keeps them forever out of reach. This creates a boundary in space, known as a Rindler horizon. It is a wall of shadow following close at your heels, a point of no return that disconnects you from the rest of the cosmos. To you, everything behind that wall is gone, causally disconnected from your reality. This should sound familiar. A Rindler horizon is mathematically almost identical to the event horizon of a black hole. In a black hole, gravity is so strong that light cannot escape. In your accelerating spaceship, you are moving so fast that light cannot catch you. The geometry is the same. And just as Stephen Hawking famously predicted that black holes must radiate heat, Hawking radiation, Bill Unruh discovered that your personal acceleration horizon must do the same. The fire you feel is the radiation coming from that wall of shadow behind you. This implies that the Unruh radiation burning your ship and the Hawking radiation slowly evaporating black holes are two sides of the same coin. It is a stunning confirmation of Einstein's equivalence principle, which states that gravity and acceleration are indistinguishable. If you are in a windowless box, you cannot tell if you are sitting on the surface of a massive planet or being accelerated through deep space by a rocket. The Unruh effect takes this to the quantum level. It says that because gravity and acceleration are the same, the thermal bath of a black hole and the thermal bath of an accelerating rocket are the same phenomenon. We often think of black holes as monsters far away in the dark, exotic beasts that defy the laws of physics we live by. But the Unruh effect tells us that we carry the seed of a black hole with us whenever we move. Every time you step on the gas, every time you turn a corner, you summon a microscopic event horizon into existence. Usually, the acceleration is so small that the temperature rise is immeasurably tiny, billionths of a degree. But the mechanism is there. We are not just flying through a static void. We are surfing the edge of our own personal event horizons, constantly tearing information apart from the vacuum, lighting tiny fires in the cold simply by refusing to stand still.